A project or the network analysis is a topic that is normally applied in projects. And a project is a temporary endeavor or activity that an organization is going to undertake. And when we say that it is a temporary endeavor, it means that it has a definite start point. It has a definite start point and another definite stop point. When it will start and when it will stop. It is not something that will be done forever. It is not something that will be done indefinitely. It will start here, it will end here. And when you undertake a project, we are going to have what we call activities. Every activity will consume time. Every activity will consume resources. That is like it will come at a cost. And these activities in a project, they are interrelated. There are those activities that must be completed before subsequent activities can be able to start. Like, for example, it can be a project of constructing something like a house. It can be a project of constructing something like a road, something like what? A dam. That particular project will have interrelated activities. Like, for example, in a building, you will have to clear the site. You will have to do the foundation. You will have to do the slab. You will have to erect the walls. You will have to go and do the roofing. You will have to go and do the finishing and all that. Those are now what we call activities. Some activities cannot be undertaken before others have been completed. There is no way you can do the roofing before walls are done. There is no way you can do the finishing before you have completed the walls. You cannot erect the walls before you have done the foundation. So we have got a sequence in which those activities must follow each other. That sequence of activities, the way they are interrelated, remember some other activities can be undertaken at the same time. We have those activities that can be undertaken parallel. This one is going on, the other one is also going on, because they don't have to wait for this one to be completed so that the other one can be able to start. So such kind of interrelationship and a diagram that shows that this activity must end before this one can start, it creates something like a network. It creates something like a network. Like, for example, the project is starting there. We have activity A that will have to take place. The moment activity A has been completed, activity B can take over. Activity C can also start immediately A has been completed. After that, we go maybe to activity what? From B, we go, for example, to activity D. After activity D is completed, for E to start, not for E, let's say that is E. For E, E and D must be completed for activity F to start. And then that will be the end of our project. So when we present now the activities and the time each activity that will take for it to be completed in a diagram like this, this diagram becomes a network. This diagram becomes a network. The arrows here, they mean activities. The activities are the arrows. Then the circles are known as the events. And an event, it is a point in which an activity is starting or ending. An activity is starting from here, ending here. So the two ends, there must be an event where an activity is starting or where an activity is stopping. So whatever you have here becomes your network. It can be now be very clear that for this project to be completed, we shall start with activity A, sorry. Once activity A is completed, activity B and activity C will start and will run simultaneously. As B is being undertaken, C is also being undertaken. Then, once C is completed and D is completed, then we shall have activity E starting from where activity C has stopped. We shall have activity D starting from where activity B has stopped. And both of them, that is D and E, they must be completed before the final activity, which is activity F, can be undertaken. That is now what we call a network. And then we have the terms that are commonly used in network analysis. One of them is the network. This is a diagram showing how activities and events are interconnected in a project. A network is a diagram that shows how activities and events are interconnected in a project. An activity, it is any activity or role that consumes time and resources. And then an event, it is simply the starting point or the end point of a project. The other terms we'll find, it is what we call a dummy activity. A dummy activity is an activity that does not consume time or resources. An activity that does not consume time or resources, we normally include it in the network diagram to make the network diagram obey the rules, because this network diagram has got rules of drawing it. So if you find that you are in a fix and you are almost disobeying the rules, you might be forced to come up with an imaginary activity. Imaginary activity is what we call a dummy activity. It is not a real activity, but we put it so that our network diagram can be able to make sense. And therefore, the definition of a dummy activity is that it is an activity that does not consume time or any resource, or an activity that does not consume any resources in an organization. And it is normally presented with a dotted arrow, like that. We normally present it with a dotted arrow. So if, for example, you find that I've used something like this, and then I pointed there, this is simply a dummy activity. I don't indicate time. It does not consume time or any meaningful resources. Once you have also understood that, then you need to know the terminologies. Let me take you through the notes so that when we meet in our next class, I'll just go straight to drawing the networks. I'll just go straight to drawing the networks. So this is the basic concept. We have talked about activity, the tasks that are involved in the project. They are normally represented in a network with an arrow. The event, which is the point that indicates the start or the end of an activity, is presented by a circle. A dummy activity, it is activity that does not consume time or resources, and it is merely to show logical dependencies between activities so as to abide by rules of drawing a network represented by a dotted arrow. And then the network, it will be a combination of activities and events. That is the arrows and the circles. What you have here is a network. Then the rules that you must abide by in drawing the network, you are told that a network should only have one start point and one finish point. meaning that at where it starts, it must be only one circle and it must end with a one circle. In a project and a network, you cannot have a case like this. That is a rule. You cannot have a case whereby you are starting like this. This is wrong. You must start with one circle. What you can happen is that you can have one circle and then two activities they run from the same, but it must start with one circle, it must end with one circle. You cannot have a case whereby the project is starting with two circles. That one is very wrong and it is against the rule of doing the networks. That is what it means. Rule number 2. All activities must have at least one preceding event. The tail event, remember the event is a circle. It must have at least one preceding the tail event and at least one succeeding event, the event at the head. But an activity may not share the same tail event and the head event. Let me go back here so that I illustrate. Every activity must have a 0 at the back and a 0 in front of the arrow. Every arrow that you see here, there is a 0 at the back and a 0 in front of it. But you cannot have two activities, like for example, activity A and B. We start a network like this. This is A. Then from A, we have B and C. B and C, they move like this. They cannot happen like that. These two activities cannot start from the same and end at the same. Two activities cannot start from the same event and end to another same event. If that scenario happens, that is where we bring a dummy. We put a dummy somewhere. Tunaweka hivi, tunaweka hiyo ni B, and then we connect this with a dummy, so that we can be able to abide by the rules. Two events cannot run from the same event and end at the same event. If that is trying to happen, break that particular case by a dummy. Put that and then you put a circle. So every activity, there must be a tail event and a head event. There must be a point where the arrow is coming from and where the arrow is ending. That is the rule. An activity can only start after its tail event has been reached. You cannot start an activity if the previous activity has not been completed. You must wait until it is completed, then you start. An event is only complete after all activities leading to it are complete. Sometimes activities can end or can have multiple. Like for example, what we have here, F. For F to be able to start, then it must wait until activity D is complete and activity E is complete. That is when you say that F can be able to start. If this one was taking 10 days, this one was taking 7 days, then F can only start after 10 days, after the activity with the longer duration has been completed. After the activity with the longer duration has been completed, it cannot start after 7 days, because after 7, this one, the other one is taking 10 days. It must wait this activity to be completed before it can be able to start. And then you are told that activities are identified numerically. That is ABC, or alphabetically, that is ABC, or numerically, that is 1, 2, 3, and all that. We can label them the way I have labeled mine, A, B, C, D up to F. Loops and danglers are not allowed. Loops and danglers are not allowed. So Your network should always be forward moving. A loop is something like this. In a network, you cannot have activities they going forward and then they start again moving backward. That is what we call a loop, which is not allowed. The project, the arrows will always point to the head, in front, from left to right. You cannot have it goes like this and then it goes back to where it started. That one is a loop, which is not allowed. A dangler, it is an activity that is hanging. It is now like it is not connected to the main network. So this is like a dangler. This activity is a dangler. Like for example, if I use mine, a dangler will be something like this. I have my network and then it starts here, it ends here, but I have something like this. I have an activity that is not hanging, it is hanging, it is not connected with the main network. This is what we call a dangling activity. They are not allowed in drawing the network. If this happens, then you put the dummy, connect it with the main network. That is actually the purpose of the dummy. Whenever you find that a particular rule is being violated, you correct that particular violation by introducing the dummies. You introduce the dummies like that. And the network will run from left to right. So you cannot find again moving back. That is a loop, which we say is not allowed. I think we have exhausted those rules. And all that. So when we meet in our next class, our focus will be now on drawing the networks. We determine the critical path. We determine the project duration and all that using the past paper questions. Using the past paper question. I think you have seen quite a number of them. You have seen quite a number of questions regarding the networks. Let me show you an example of it. Any question that you come across like this is a network question. So you need to draw a network diagram, determine the critical path. The critical path is the longest path from the start of the project to the end of the project. Which path is the longest? How many days will the project take? And if it is the longest, which path is this? So like, for example, in our network here, let me remove this. Let me remove this. How can you move from this starting point to this finish point? You have got two routes. You can go from A, B, D, and F. You can go to A, C, E, and F. So the two, or the one that is going to give us a longer duration, maybe this one is 2 days, this one is 4 days, this one is 10, this one is 3, maybe this one is 8, this one is 5. Which path are you going to take from the start of the project to the end? And that path becomes the longest path. So if I take this, it will be 2 plus 8, 10, 10 plus 5, 15, 15 plus 3, 18. If I take this, it will be 2 plus 4, 6, 6 plus 10, 16, 16 plus 3, that is 19. Then this is my critical path, the longest path. The longest path, I simply say it is A, then I move to C, then I move to E, then I move to F. And that path always must start from the beginning to the end. It is not a path that is ending somewhere in between. It must move from the start all the way to the end. And the one that is going to give you the highest number of days or the longest duration becomes your critical path. So that is where we stop today. When we meet in our next class, our focus will be how to draw those networks, how to determine the project duration, how do you determine the critical path. So for today, That is all that I had for you. Any question? If there is no question, allow me to wish you a very blessed evening. Let us meet again next week. Thank you very much. Bye-bye.